DARPA wants to replace GPS dependence with new class of sensors. Every GPS signal on the battlefield is a vulnerability waiting to be exploited, and Russia, China, and Iran have all demonstrated the willingness to exploit it. DARPA just announced it is going to solve that problem from the inside out by building a navigation sensor so precise that it no longer needs GPS to know exactly where it is. The Defense Advanced Research Projects Agency, the Pentagon's research arm responsible for developing technologies that define the next generation of American military capability, published a special notice on May 29 announcing the forthcoming PINPOINT program, formally titled Precision Inertial Navigation and Positioning on an Integrated Tesseract. The program, managed through DARPA's Defense Sciences Office by Program Manager Sunil Bhave, aims to develop a revolutionary approach to inertial navigation that would allow military platforms to maintain precise positioning even when GPS has been jammed, spoofed, or denied. A formal solicitation with specific technical requirements and performance metrics is expected in the near future, with industry responses to the preliminary notice accepted through July 13, 2026. To understand why PINPOINT matters, some background on how modern military navigation works is necessary. The Global Positioning System is a network of satellites orbiting approximately 20,200 kilometers, 12,550 miles above the Earth that broadcasts precise timing signals. A receiver on the ground, in the air, or at sea calculates its position by measuring the time it takes signals from multiple satellites to arrive. The system is extraordinarily accurate and has become the backbone of modern warfare. Guided missiles use GPS to hit targets, drones use GPS to navigate, artillery use GPS for position reporting, and fire control soldiers use GPS for blue force tracking and navigation. Virtually every precision capability the U.S. military fields depends on GPS signals that an adversary can jam. When GPS is jammed or spoofed, military systems fall back on inertial measurement units, known as IMUs. An inertial measurement unit is a device that measures acceleration and rotation using gyroscopes and accelerometers, allowing a platform to estimate its current position based on where it started and how it has moved. Since the problem is that IMU errors accumulate over time, a small measurement error in acceleration or rotation rate compounds with every subsequent reading, so a drone that starts its flight knowing exactly where it is will drift further and further from its true position the longer it relies exclusively on inertial measurement. High-quality IMUs using fiber optic or ring laser gyroscopes can limit this drift to acceptable levels, but those systems are large, expensive, and power-hungry, unsuitable for the small, cheap, expendable drones that define modern warfare. Low-cost microelectromechanical systems, IMUs built using the same semiconductor manufacturing processes that produce computer chips, are small enough to fit in a consumer smartphone and cheap enough to put in a one-way attack drone. The problem DARPA explicitly identifies in the PINPOINT program notice is that MEMS IMU performance has plateaued for over a decade, and the reason it has plateaued is structural. Current design approaches constrain the mechanical structures inside the IMU to operate strictly within their linear regimes, avoiding the complex nonlinear behavior that occurs when those structures are pushed harder. PINPOINT aims to break that constraint entirely by actively leveraging nonlinear mechanical dynamics, advanced surface materials, and what DARPA describes as complex physical potential wells to achieve navigation precision that linear design approaches cannot reach. The name PINPOINT itself encodes the technical approach. A tesseract is the four-dimensional equivalent of a three-dimensional cube, a mathematical structure that describes how multiple dimensions interact simultaneously. Applied to sensor design, the integrated tesseract concept suggests a sensor architecture that operates across multiple physical domains simultaneously rather than treating each measurement axis in isolation, allowing the system to extract more precise information from the mechanical motion of its sensing elements. The program builds directly on DARPA's previous HALOVS portfolio, which stands for Highly Accelerated Learning of Vibratory Systems, a research program that studied the fundamental physics of vibrating mechanical structures under extreme conditions. PINPOINT is designed to translate those theoretical discoveries into sensors that can actually be manufactured and deployed on military platforms. The operational urgency driving PINPOINT is visible across multiple active theaters. Russia has operated extensive GPS jamming infrastructure throughout the war in Ukraine, affecting both Ukrainian military operations and civilian aviation across the Baltic region, with Finland, Estonia, and Poland all reporting persistent GPS signal interference affecting commercial aircraft. Iran deployed GPS jamming capabilities during the conflict with Israel and the United States with American pilots and drone operators reporting signal interference in the Persian Gulf region. China has extensively tested and deployed GPS jamming systems around Taiwan and in the South China Sea, where any future Taiwan Strait conflict would involve sustained electronic warfare against American navigation systems. Jeff Thompson, CEO of American drone company Red Cat, stated publicly in late 2025 that every battlefield is a GPS-denied environment, an assessment that reflects the operational consensus across the U.S. military. The PINPOINT program's explicit requirement for integrated partnerships between academic research institutions and commercial industry from the outset reflects a DARPA recognition that the problem it is trying to solve sits at the intersection of fundamental physics, advanced materials science, precision manufacturing, and real-time adaptive control systems. No single organization commands all those disciplines simultaneously. DARPA is essentially telling the research community to form multidisciplinary teams before the formal solicitation drops, because the teams that will win this program will need to have already integrated expertise that no single university or company possesses alone.